Okay, good morning, everyone. We're up and running, and this is the chain rule. What a happy day. So far, we've done what rules? We've done power rule, product, and quotient. And we will still continue to use these. In fact, today we'll combine some of them with the chain rule that allows us, good morning, JD, it allows us to do some more complex derivations, which, gives us power. Gives us power. And you've all read this. Um, dy dx equals dy du times du dx. It allows us to deal with really their composition of functions, really. And it's funny because we were doing that in what class, Mr. Shelton? College algebra, we were doing composition of functions, and here's why. Chain rule. It's exactly that. Okay, so let's try one. Let's do f of x equals the square root of x squared plus 1. Okay? And you can think of it like this. Let u equal, and I do these off the side all the time. And you don't have to do it this way. After you get used to these, you can probably just look at it. But at least be aware of the u substitution gig. Let u equal the messy part. Okay, in this case, x squared plus 1. And then so we just have the square root of u equals what? U to the 1/2. And then we can say dy du equals what? The derivative here would be what? There you go. 1/2 u to the negative 1/2. Good. Okay, we're ready to cruise then. So we can say f prime of x equals 1/2 u to the negative 1/2, then times the du dx part here is going to be the derivative of just the inside, which is what? No, of this part. Just the, yeah, there you go, times 2x. Okay? And then we substitute the u back in, and we get f prime of x equals 1/2. What was u? X squared plus 1 times 2x. To the negative 1/2. My bad. And then you could leave it there, and like on the AP Calc exam, they're fine with that. For Shemeketa, they'd probably rather see you get rid of the negative exponent and clean that up a little bit. So f prime of x equals, how could we clean that up? We could go 1 over what? Be careful. 2 times the quantity x squared plus 1. Daniel, you're frozen. To what power, George? No, be careful. This negative 1/2 goes in the denominator. 1/2, positive 1/2. Good. Times 2x. And then you could just say 2x over that. And that's getting really, really good. Or if you're a total geekazoid, you could say 2x over 2 times the square root of x squared plus 1. And some people would say, well, that's kind of the form you got it in, so you should return it. Buenos días, José. ¿Cómo lo va? ¿Cómo lo fue? ¿Cómo amaneció? I had trouble with that one. But I love it. How is your sunrise? Isn't that better than saying, What's up, Madeline? How is your sunrise? God, I love that. How do you say that, Christy? Yeah, it's so much better. Oh, I want to be a Latina. Okay. No, it just sounds better. I could get a sex change and move to a Latin American country, and in about 10 years, maybe I could achieve my goal. I don't know. No, they won't. They're all used to me. No, they're all used to me. Who cares? Who cares? Okay, question. Anna, question? It's okay? Mariah? Jerica. Okay. Because I have a composition of function here, I have the square root of something as one function. And I have x squared plus 1 as another function. We think of them as two individual animals. So I have to deal with the derivative of the square root of something. And then I have to deal with the derivative of that something itself. Okay? So it's the square root is something to the 1/2, so that's power rule. 1/2 something to the 1/2 minus 1. And then I have to go times the derivative of what's inside. And that's chain rule. Yeah. Did you get a haircut, JD? No. Yeah, looks like it. Okay, good questions. More questions. Take take notes if you want to, but as I said, I will post this if you want to just watch, if that's easier. If taking, oh, we got to do a lot more. These, you just, they're push-ups. You just got to do a bunch of them. And normally I'm not like that, but man, these you got to do a bunch. Okay, let's try another one. Chain rule. How about y? You'll see these a lot. Y equals x cubed minus 1 to the 100 power. Freak out, big numbers. Okay, once again, let u equal x cubed minus 1. Then dy du equals what? Somebody other than Daniel, get involved. 3x, there you go. Okay. 3x squared. Better. Okay. 3x squared using the power rule. Okay. So we got to use, really, the power rule twice in order to form a chain rule here. So let's do that. Dy dx equals u to the 100 equals 100 u to the 99. Oh, wait, this should have been du dx, my bad. Or dy du, my bad. Dy du equals u to the 100 equals 100 u to the 99th. I just went 100 minus 1. And then I have to go times dy no, I was right the first time. God, I'm a mess, you guys. I'm sorry. I apologize. Got in a hurry. Okay. So then I got to go times the derivative of the inside. So I get dy dx equals 100. What was u? X cubed minus 1 to the 99th times the derivative of the inside, 3x squared. Now let's clean that up a little bit. Dy dx equals, what do we have then? Who haven't I picked on? Jose, help me out, man. How can I simplify this then? Pardon me? I can't hear you. A little louder. Yeah, just algebra. We're done with the calculus. So what can I do? I've got 3x squared out here and I've got 100 out here. No, I'd like to combine the two if at all possible. I can't deal with this one, Jose, because it's raised to a power, but I can deal with this one because it's the whole thing times 3x squared. So what can I do? What's 3x squared times 100? There you go. So we can go 300 x squared times x cubed minus 1 to the 99th. There we go. So, questions? What's next? Leibnizian notation. So, as you get faster at this, you'll go, okay, I got to go 100 times whatever's on the inside. Just leave it alone to the 99th times the derivative of whatever's on the inside. That's chain rule. And after you do a bunch of these, they get faster. Questions? What? Let's do a little harder one then. I know that one was, a little more approachable. Okay. How about this? New color. F of x equals 1 over the cube root of x squared plus x plus 1. Find f prime of x. Ian, how are you, man? So, Ian, tell me. In its current form, we can do this, but this is one where we would be better to rewrite it first. And how should we rewrite it? Close. Very close. Let's do it. You're trying to do maybe too much at once. Let's go 1 over the third root of x squared plus x plus 1. Okay, and let's do that first. And then let's do one more move. No. You've got the right idea, definitely. Can we do it that way? Maybe we can do it that way. Maybe we can do it that way. Okay, are you saying 1/3 times the square, or the cube root, I'm sorry. I meant, I am asleep today. I meant x squared plus x plus 1 to the third. That's what I meant. I know. Well, say something, Marissa. You know me. I make lots of mistakes. I get thinking about the next problem and stuff. Okay, so this is to the 1/3. And then, Ian, were you saying x squared plus x plus 1 to the 1/3 to the -1? I don't know if you were saying, but that is actually correct. That is actually correct. Maybe an easier way to think about it is to say this is x squared plus x plus 1 raised to what power? I heard it there. -1/3. Good, JD. To the -1/3 power. I think if you invest a little bit of time first and write it in this form here, that your life will be better. Okay, so now we have something raised to a power, and then we can just do the derivative of that something as the chain rule. Okay? So it might help, if you think about it like u to the -1/3, like that, times du dx. Let's think about it like that, okay? So if you were just doing the derivative of this part, Branson, help me out. If you're doing just the derivative of this part, what would you do? Just power rule. Yeah. Negative 1/3 u negative 4/3, close enough, good. Okay, and then we go times the derivative of what's on the inside. Okay, the derivative of what's on the inside, which is what? 2x plus 1, good. And then we just plug in what we started with. F prime of x equals negative 1/3. What was u? X squared plus x plus 1 times 2x plus 1. It's not so bad. It's looking better. Let's clean it up, though. Let's clean it up. Oh, yes. I lost it. Where's my green? To the negative 4/3. Thank you. That's why I need you all. I forget that stuff. Details, not my thing. That's why, I should never design things that have the potential to blow up. They would. Okay, so let's clean this up then. Clean this up. What do we got? Anna, I'm going to pick on you. Yes. Let's write this with a positive exponent. Okay, so I can say 1 over 3 times x squared plus x plus 1 to the positive 4/3 power times 2x plus 1. And then I can do one more step. 2x plus 1 over negative 3 times x squared plus x plus 1 to the 4/3. Okay, so I think this is about as good as you can get. A lot of people have trouble with this part right here. Keep in mind, there's a numerator, there's a denominator with 1 and 3. The 3 stays in the denominator. The 1 stays in the numerator. The x squared plus 1, or x squared plus x plus 1 to the 4/3 comes down to the denominator. The sign becomes positive. Okay? And I think that's about as well as we can do on this. Questions? It allows us to do a lot of tricks, that wacky chain rule, combined with power rule, quotient rule, product rule. What? Odd? Yeah, maybe. Maybe not. Okay, Tyler, you're up, man. G of t equals, here it is. This is going to be the hardest one yet. But wait, there's more. Ian. I can. Second example. I think it's the red one. Oh, because I started with y. I'm just mixing up the notation so that we're multilingual. Yeah. Yeah, and I'm going to use G of t here, just so you don't get freaked out by different notation. So this one, oh my gosh, this one uses How many rules? More. 3. It uses power rule because there's an exponent. It uses quotient rule because there's a quotient. And it uses the chain rule to put the two together. All right. Tyler, gonna pick on you. Here we go. You could. You could. Okay, and maybe we should do that. Let u equal t minus 2 over 2t plus 1. Then du dt. Oh, you're going for the whole thing. Okay, that's fine. So then we're going to go g prime of t equals 9u to the 8th times du dt. Okay? And then let's do du dt separately because it's pretty big. Okay? Du dt equals okay, 1. Oh, be careful. Okay, times the denominator. I was going to say, man, be careful. 2t plus 1. Okay. Minus 2 times. Oh, no, wait a minute. You're getting them mixed up. You got to do one of each. So, like here we went the derivative of the numerator times the denominator, which is fine, minus, and then you need one of each. So if you go 2 here, then what does the other one have to be? That is the derivative right there. 2 is the derivative. You want to go the other way? That's fine too. Okay, we can, and they're fine. And I do want to say that you can go t minus 2 times 2, and that's fine too. The order on these two doesn't matter, but what matters is the subtraction sign, so you got to be a little bit careful and get that right. Over denominator squared is 2t plus 1 squared. Okay, so now let's put them together. So g prime of t equals no, we're going to start out with this. Uh-huh. Over 2t plus 1. Uh-huh. To the 8th power times, and here's the chain rule. So we use the product rule, what we started with, times whatever. We didn't change. Notice, we didn't change what's inside the parentheses at all. We did the power rule here, 9, whatever's on the inside, to the 9 minus 1, times, then the derivative of the inside, which is the quotient rule, which is 2t plus 1 minus 2t. I think we better be a little careful there. I'm going to just put that in. Minus t minus 2. Wow, George, go for a world record. Okay. Over 2t plus 1 squared. Is that right, Tyler? Okay. And then we can clean that up if we want to a little bit. Think about ways we could clean this one up. And we probably should. You wouldn't have to, but probably should to make life a little bit better for you. I noticed this is a 2t plus 1 to the 8th. So you could write it that way. You could say it's 9 times t minus 2 to the 8th over 2t plus 1 to the 8th. Is that cool? Is that all right? I think we're good there. Over. What about this numerator? We get 2t plus 1 minus 2t plus 4. Thank you. Over 2t plus 1. Gosh, that's ugly. That looks like plus plus. Over 2t plus 1 squared. We're almost done. G prime of t equals 9 times t minus 2 to the 8th over 2t plus 1 to the 8th times, what do we have out here? What's that? 5 over 2t plus 1 squared. Now, think way back. Mariah, if I have the same base raised to an exponent, what can I do? And it's times. Good question, not plus. I can add the exponents. Right. Right. So then I would have g prime of t equals 45. Oh, did you notice, everybody? Both passes are back. Nice. Love my students. They're awesome. T minus 2 to the 8th over... Okay, Mariah, you're up. To the 10th. That, ladies and gentlemen, is the power of mathematics. Makes your head hurt just thinking about it, doesn't it? On a comet. And except for that little 1/3 of a mile bounce, it did pretty well. They got a lot of data. And I think I'm going to... How many minutes am I in? 28.